So this is an active cascade filter, and what this does, it takes 300 hertz and between 300 hertz and 3 kilohertz and amplifies it to 2 kilohertz and 20,000 kilohertz. And the reason you may want to do this is because if your audio strength is not between the human hearing range, you need to amplify that so people can hear this. So what this would do is basically pushing these lower band frequencies into higher band frequencies so that people could hear. And if the signal needs to run at this lower frequency, it'd be more useful for it to run at that frequency and then upscale it later on. Same with like wires and transformers. You have high voltage running through your power lines, and then when you need the low voltage, high current, you translate it with a transformer. But this is that, but for audio. Now, these values are kind of weirdly specific for what this is, and I'll show it in a second, how I got to these values. So what you want to do is you want to take your frequency, I'm going to put HZ, and you're going to take 1 over 2 pi, and then you want your X value to be your resistor value, and then times C, and then C will be times 100,000, or divided by 100,000. And you plug in, you try to solve for these variables, and you get R equals 5.3 kilo ohms, or 5,300 ohms, and then C2 will equal 0.1 UF, or nanofarads. And now that you have these two values, you want to have a 10 decibel increase. So you're going to make sure this equation is below 1, which will satisfy the equation. So you have 5,300 divided by itself, which is 1, over 1 plus, or no, it's like 1 over 300 divided 1,000 to the second power, and then square root that whole thing. And then you want to multiply that by the same fraction again, except in the internals, and this fraction will be 1 over 1 divided by 1,000 squared, and then the square root of that, which would be like 1 over 1,000,000, and the square root of that, and then it's 1 over 1,000 again, but the whole fraction. And then you get these two numbers here. You get 9.57 times, these are off by an order of magnitude, and you get 9.07, or, okay. So since it's under 1, you can just make the first capacitor 10 times lower than the second capacitor. So as you see here, C2 is 0.01 nanofarads, or C1 is 0.01 nanofarads, and C2 is 0.1 nanofarads. And the reason for that is because you want the amplitude to be 1/10 of what it is. So those resistor values with this capacitor value will give you 1/10 of the amplitude. And it's pretty neat. Click it run. The green one should be 1/10 of the blue voltage, and it should be at a higher frequency. So right now it's at 300 hertz. We're gonna go to grapher, and boom, now it's in a higher frequency. See the swings of the voltage. The other one's a little bit off shifted because there is a delay when the capacitor gets charged. So the green line will be a little bit behind the blue one. Or the low pass filter will be ahead of the high pass filter because of the way it's set up. And these two will read out audio signals at a higher frequency. So now what I'm gonna do, I changed the value to demonstrate that. So I'm gonna put it at 100 nanofarads. The other one, now they're both roughly the same length. I was hoping that the value kind of half the magnitude, so that makes sense. I'm gonna click stop. Put it at 3,000 hertz. It'll do the same thing, but 10 times faster. Oh, come on. See, there you go. It's 1/10 the amplitude, which is what I was going for, and there you go. Now to measure this in waveform, since I don't actually have any of the components required to make this circuit, you would open up your scope and you create a 1 volt peak to peak AC voltage at 300 hertz. Then you go to wavelength or wavegen. Oh, I know, wavegen is the one that makes the voltage, the AC current. This will measure it, and then the voltmeter will allow you to select the voltage at a specific point. And if you were to set this up, you'd want to take the voltage, I'm getting thrown off, right here where this green voltage is, the blue and the green. And you'll ground everything else. This will be wired back into the capacitor. So like this will be actually exactly as shown. Just imagine a breadboard behind this whole thing. And these 3 wires are connected to the negative. So that's basically it. This is pretty useful for audio amplifying. So I think it's pretty neat. And I have another project going on here since this is a longer phone charger. Just thought I'd add that in there. So all this AC current stuff has got me like, hey, I can make coils. So it's pretty neat. And that's it for this class. And that's my design for a audio amplifier, or cascaded active filter. And that's all. Have a good night.